Continue on to a more difficult problem. 25 and 40 hundredths divided by 5. Now this is different because the 5 does not easily go into each of the digits of the dividend. For example, I must start by writing my 5 and changing my division into multiplication. Now, unlike the first problem where 3 times 1 equals my first digit of 3, if I ask myself 5 times what gives me 0, besides 0, nothing can be multiplied by 5 to give me 0. So I must look to my digits to the left and combine them to create 40. I now repeat the process. 5 times what gives me 40? 5 times 8 gives me 40. But because I use both the 4 and the 0 in my multiplication problem, I must fill this place value with a digit. The only digit I can add to 8 without changing the value is a 0. This still reads 5 times 8 equals 40. I continue as I go from right to left. 5 times what gives me 5? That answer would be 1, but I notice that my last digit is a 2. And 5 times nothing can give me 2 by itself. I must look at the last two digits, a 2 and a 5. If I combine them, I now can ask 5 times what gives me 25? Well, 5 times 5 gives me 25. And then again, I fill my last place value with a 0 because it does not change the value of 5. This still reads 5 times 5 equals 25. I now again have all the digits in my quotient. I must find the proper location for the decimal. I refer back to Rule 3 on page 15 of my notebook, where it states, count the numbers to the right of the decimal in the original problem, and then add the same digits to the right of the decimal in your answer, or quotient. Well, for my original dividend, I have a 4 and a 0, 2 digits to the right of the decimal. In my quotient, I count 1, 2, and place my decimal. My final answer is 5 and 8 hundredths. Now I can include this 0 before my 5, but because it's to the left of the first digit, the 0 does not change the value, so I do not need to include it in my answer.